It hovers over your flower bed with a stillness that shouldn't be possible for something with wings beating that fast, suspended in midair like it's pinned to an invisible thread. A long, thin needle-like structure extended forward from its round, fuzzy body, dipping briefly into a blossom before darting sideways to the next one in a motion too quick and too erratic for any bee you've ever watched. Most people glance at it, register bee, and either give it a respectful wide berth or worse, treat that long needle-like protrusion as a stinger and reach for something to swat it with. It is not a bee. It has never been a bee, has no relation to bees beyond a superficial resemblance, and does not sting at all, cannot sting at all, since the structure you're looking at is not a weapon in any sense. But the true story of what that insect actually is, and what it's actually doing as it hovers over your garden, is stranger and considerably darker than anything the harmless lookalike framing usually implies. Today we're going to identify exactly what you're looking at, explain why it spent millions of years evolving to look like something it isn't, and reveal what's actually happening the moment it disappears into the ground near a patch of bare, sunny soil in your yard. The insect hovering over your flowers is a bee fly, a member of the family Bomeliidae, one of the largest and most widespread families of flies on the planet, with thousands of described species found across nearly every continent. Despite the name, despite the fuzzy, rounded body, despite the general size and coloring that so closely mimics a bee at a passing glance, a bee fly is taxonomically and biologically a true fly, sharing far more in common with a housefly than with any bee it happens to resemble. The giveaway, once you know where to look, is remarkably simple and reliable. Count the wings. Bees, like all members of the insect order Hymenoptera, have 4 wings, 2 on each side. Bee flies, like all true flies in the order Diptera, have only 2 wings total, having evolved their rear pair of wings into small, specialized balancing organs called halters, tiny club-shaped structures that vibrate rapidly during flight to help stabilize the insect's movement, a feature unique to flies and one of the clearest anatomical differences between the two groups. That long, needle-like structure extending forward from the bee fly's head, the feature most responsible for triggering a person's instinct to keep their distance, is not a stinger at all. It's a proboscis, a rigid elongated feeding tube used exclusively to reach deep into tubular flowers to access nectar that many other pollinators, lacking a structure of comparable length, simply cannot reach. It is entirely incapable of stinging, entirely incapable of biting in any way that could harm a human, and functions purely as a drinking straw, fixed permanently in an extended position rather than retractable the way some other long-tongued insects' feeding structures are. The resemblance between a bee fly and an actual bee is not accidental, and it did not emerge for the reason most people assume when they first learn it's a mimic. Understanding the actual evolutionary logic behind this disguise requires setting aside the intuitive explanation and looking at what the bee fly is actually trying to accomplish by looking the way it does. The most immediate, straightforward benefit of resembling a stinging insect is protective mimicry, a well-documented evolutionary strategy called Bayesian mimicry, in which a harmless species evolves to resemble a genuinely dangerous or unpalatable one, gaining a defensive advantage without needing to develop the actual defense mechanism itself. Predators, particularly birds, which learn quickly and remember specific visual and behavioral cues associated with painful or dangerous prey, are considerably less likely to attack an insect that closely resembles a stinging bee, even though the bee fly itself possesses no sting at all and would offer no resistance if actually caught. In essence, the bee fly has evolved to borrow a bee's reputation without needing to earn any of the biological cost of actually maintaining a venom-producing sting apparatus. But there's a second, considerably more specific and more consequential reason behind the resemblance, one directly connected to the darker behavior we're about to cover, and it explains why bee flies didn't simply evolve to look like any generic stinging insect, but specifically evolved in many species to closely resemble the exact bee species they most frequently interact with in a very different, far more intimate context. That characteristic hovering behavior, the stillness that first draws your attention to a bee fly in the first place, serves a purpose considerably more specific than simply feeding on nectar, and understanding it requires looking at where a bee fly actually spends most of its hovering time. While bee flies do feed extensively on flower nectar, using that long proboscis to access blooms other pollinators can't reach as easily, a significant portion of an adult female bee fly's time and attention is spent hovering not over flowers at all, but low over patches of bare, sunny, well-drained soil, precisely the kind of ground favored by solitary, ground-nesting bee species for constructing their individual nest burrows. The female bee fly patrols these areas with careful, deliberate attention, watching and waiting for a specific target, the small, unguarded entrance to a solitary bee's nest burrow. Once she identifies an active burrow, she performs one of the more remarkable pieces of insect behavior documented in this family. Rather than landing at the entrance, which would risk detection and defense by the resident bee, she hovers directly above or near the burrow opening, and in a rapid, precisely aimed motion, flicks her own eggs directly into or near the entrance while remaining airborne, sometimes covering the eggs in a fine layer of sand or dust picked up from the surrounding soil moments earlier, using specialized structures on her abdomen specifically adapted for collecting and applying this camouflaging coating. The entire process happens in a fraction of a second, without the female bee fly ever making direct contact with the nest or its resident bee at all. Once a bee fly's egg is deposited near or inside a solitary bee's burrow, the story shifts entirely to the developing larva, and this is where the genuinely dark reality of what a bee fly actually is becomes clear. The bee fly larva that emerges from this egg is a specialized predator, or in a broader biological sense, a parasitoid, an organism that develops by consuming the tissue of a host, ultimately killing that host in the process, a category of behavior distinct from simple parasitism where a host typically survives the relationship. Upon hatching, the tiny mobile bee fly larva makes its way into the depths of the host bee's burrow. Seeking out the individual brood cells, the solitary bee has painstakingly provisioned with pollen and nectar for her own developing offspring, each cell typically containing a single bee egg or young larva, along with a carefully stocked food supply meant to sustain that single bee through its entire development. The bee fly larva, upon reaching a host cell, consumes the food store the mother bee originally provisioned for her own offspring, and in many documented cases, eventually consumes the host bee larva itself directly, a specific developmental progression researchers have carefully documented across multiple bee fly species. The bee fly larva then completes its own development within the same cell the host bee constructed and provisioned, using the shelter, resources, and protection the host bee built entirely for her own offspring, before eventually pupating and emerging as an adult bee fly from the very burrow where a solitary bee's own young once would have developed. This means that every adult bee fly you see hovering gracefully over your garden flowers, feeding delicately with that long, harmless proboscis, spent its entire larval life consuming the food, and in many cases the very offspring of a solitary bee that had no defense against an attack it likely never even detected. This is where the earlier discussion of bee-like appearance becomes considerably more significant than a simple defensive strategy against predators. Researchers studying bee fly behavior have specifically noted that in several species, the resemblance to bees extends beyond general protective mimicry into something more precisely targeted, a resemblance closely matched to the specific solitary bee species that particular bee fly species most frequently parasitizes. The proposed explanation for this closer, more specific mimicry involves reducing detection and defensive response from the host bee itself during the critical moment of egg-laying near an active burrow. A solitary bee returning to her nest and encountering an insect that superficially resembles another bee, rather than an obviously different-looking fly, may be less likely to immediately treat the intruder as a serious threat requiring active defense, providing the bee fly with a narrow, crucial window to complete her rapid egg-flicking behavior near the burrow entrance without triggering the kind of aggressive response an obviously foreign insect might provoke. This layered mimicry, general protection from predators combined with more targeted deception aimed specifically at the host species being exploited, represents a particularly sophisticated example of how a single evolved trait, physical resemblance, can serve multiple overlapping survival functions simultaneously, each shaped by a different evolutionary pressure acting on the same species across a shared evolutionary timeline. Given everything covered so far, a reasonable question emerges. If bee flies are in effect feeding their young on the offspring of beneficial pollinator bees, why does this video's title still insist you should never kill one? The answer requires looking at the full ecological picture, not just the single relationship between bee flies and their specific solitary bee hosts. First, bee flies themselves are significant pollinators in their own right, and in some ecosystems, particularly in early spring when few other pollinators are yet active, bee flies represent one of the earliest and most important sources of pollination for numerous wildflower species. Their unusually long proboscis allows them to access and pollinate certain deep, tubular flowers that many shorter-tongued pollinators cannot effectively service, meaning bee flies fill a specific ecological niche within the broader pollination network that would leave a measurable gap if removed entirely from a given ecosystem. Second, the relationship between bee flies and their host bee species. while genuinely costly to individual host nests, functions as a natural population regulation mechanism operating across the broader ecosystem, similar in principle to the predator-prey and parasitoid relationships that exist throughout the insect world, and that in the aggregate, tend to prevent any single species from growing unchecked at the expense of ecological balance more broadly. Solitary bee populations have coexisted with bee fly parasitism for millions of years without this relationship driving host species to extinction, a stability that reflects a long-standing ecological equilibrium rather than a genuine threat requiring human intervention. Third, and most practically, killing an individual adult bee fly you happen to see hovering over your garden flowers does essentially nothing to protect any specific solitary bee nest nearby, since by the time you're observing an adult bee fly feeding on nectar, her reproductive behavior targeting host nests, if it has occurred at all, has very likely already taken place elsewhere, at a different time, near a different burrow you were never aware of. In practical terms, an adult bee fly visible on your flowers is, at that specific moment, functioning purely as a pollinator, providing a genuine ecological benefit to your garden with no immediate ongoing threat to any specific nest you could meaningfully protect by removing her. If you want to be certain you're looking at a bee fly rather than an actual bee before deciding how to react, here are the specific, reliable identification points to check. Check the wing count and posture, as bee flies have only 2 wings, and these wings are frequently held out flat and slightly spread even while the insect is at rest or hovering, rather than folded neatly along the back the way many resting bees position their 4 wings. Check the eyes, since bee flies typically have noticeably large, prominent compound eyes that often appear to nearly meet or come very close together at the top of the head, giving the face a distinctly fly-like appearance up close that differs from the more separated eye placement typical of most bee species. Check the flight pattern, since bee flies display a genuinely distinctive hovering style, remaining almost perfectly stationary in midair for extended periods, then darting sideways or backward with remarkable speed and precision, a flight pattern that differs noticeably from the more continuous, less erratically punctuated flight most bees display while foraging among flowers. And check the proboscis position, since the bee fly's feeding tube extends rigidly forward at a fixed angle and cannot be retracted or folded away, remaining visibly extended even when the insect isn't actively feeding, unlike the more flexible, often less prominently visible mouthparts of many bee species. If you've spotted what you believe is a bee fly in your garden, here's a simple, practical approach. First, confirm the identification using the checks above, particularly the wing count and the rigid, forward-extended proboscis, both of which are reliable even from a reasonably close observation distance without needing to handle the insect at all. Second, leave it entirely undisturbed while it feeds, since a bee fly visiting your flowers is actively providing pollination services at that moment, and there is no meaningful action available to you that would protect a specific bee nest by interfering with an adult bee fly's feeding behavior. Third, if you're specifically interested in supporting solitary bee populations in your yard, focus on habitat rather than bee fly removal, providing varied, undisturbed patches of bare or sparsely vegetated soil for ground nesting bees, alongside a diversity of flowering plants blooming across as much of the season as possible, since this supports overall solitary bee population resilience far more effectively than attempting to target individual bee flies. A strategy unlikely to meaningfully affect a relationship that has operated in ecological balance for millions of years regardless. And fourth, enjoy watching the hovering behavior itself, since it's genuinely remarkable to observe up close. The precise, motionless hover, punctuated by sudden bursts of rapid movement, representing a level of flight control that continues to interest researchers studying insect flight mechanics more broadly, offering a level of aerial precision that few other garden insects can match. The insect hovering delicately over your flowers, gentle and harmless in the moment you're actually watching it, carries within its evolutionary history a considerably darker, more complicated story than its peaceful appearance suggests, a borrowed identity shaped by millions of years of pressure to avoid predators, and a reproductive strategy built entirely around exploiting the careful, painstaking labor of another insect species entirely. None of this makes the bee fly something to fear or something to remove from your garden. It makes it, like so many of the creatures covered on this channel, considerably more complicated and considerably more interesting than the single glance most people give it before moving on with their day. A small, fuzzy insect quietly carrying both a genuine ecological benefit and a genuinely unsettling secret, suspended together in the same motionless hover above your flowers. Have you ever mistaken a bee fly for an actual bee in your own garden? Now that you know what it's really doing, does it change how you look at it? Tell me about it in the comments below. I read every single one, and sometimes your stories become the subject of the next video. And if you've ever wondered what another small creature quietly living in your garden actually knows about your world, I think the next video might surprise you just as much as this one did. Until then, keep watching, keep wondering, and never stop paying attention to the small things.